An isosceles triangle is a triangle with two congruent sides. Those two congruent sides are called legs. The third side of an isosceles triangle, or the non-congruent side, is called the base. As far as angles go, the angle opposite of the base is called the vertex angle. And the two angles opposite of the legs are called the base angles. So I'm going to label them as congruent. And that's because they are actually congruent. So that's the isosceles triangle theorem. The isosceles triangle theorem tells us that the two angles, and I should have put double marks there because all three angles aren't congruent. The vertex angle is not congruent to the base angles. Anyway, the isosceles triangle theorem tells us that the base angles of an isosceles triangle are congruent to each other. Another way to think of it is the angles opposite of the legs are also congruent to each other. One last thing I'll mention about this is don't assume that the base angles are always going to be on the bottom of your triangle. An isosceles triangle could be on its side. It's called the base, doesn't necessarily need to be on the bottom. Alright, there are three types of problems that we're going to see that relate to our isosceles triangle. The first is pretty straightforward. It's just a simple numeric problem. You can see right here I have an isosceles triangle. The measure of the vertex angle is 48 degrees, and I'm not sure why that n is right there. We'll just ignore that for the moment. But we're asked to find the measure of angle G. You can see that G is a base angle, and because of that you know that G and H are going to be equal to each other. So how can we find the measure of angle G? Well, we know that all three angles would have to add up to 180, so I'm going to subtract 48 from 180. I get 180 minus 48, and that gives me what? 132 degrees. So that tells us that angles G and H have to add up to 132 degrees. So if I just divide 132 by 2, I get 66 degrees, and that tells me that the measure of angle G is 66 degrees, and of course angle H would also be 66 degrees. So that's the most basic type of problem that we're going to see. Just a simple numeric problem, and you might be given either the measure of an angle, or sometimes you'll be given the length of a side and just asked to find a missing angle or side length. The other type of problem is a bit more involved, and that involves a little bit of algebra. You can see this is actually an equilateral triangle. It's equiangular and equilateral, meaning all three sides and all three angles are congruent. This is really just an extension of the isosceles triangle. So we're told that JH is equal to the expression 7t plus 15, and JK is equal to the expression 10t. We want to find the actual length of JK. How can we do that? Well, since this is an equilateral triangle, we know that JH is equal to JK. So I'll just write that out. JH is equal to JK. Now when I substitute, JH is 7t plus 15, JK is 10t. I'll subtract 7t from both sides to get 3t on the right. 15 is equal to 3t. When I divide both sides by 3, I find that t is equal to 5. Now I'm not finished, right? I'm asked to find the length of JK. So JK is equal to 10 times 5, which is 50. So JK is 50, and of course all three sides would actually be 50 in this case. That's the second type of problem. The third type of problem looks a bit trickier than the other two. You can see in this case I have two triangles. It looks like both of them are isosceles triangles, and it looks like I'm asked to find the measure of angle E. So where do we start? Well, we know that angle A, our vertex angle, is equal to 96. So I'm going to start by finding the measure of angle AC B. I want to know the measure of this angle right here. How can I do that? Well, this is just like our first problem, really. We have a base angle, or excuse me, we have a vertex angle. We're asked to find the measure of one of the base angles. So in order to do that, I'm going to subtract 96 from 180. So 180 minus 96 gives me 84. I'll divide that by 2. 2 into 84 is equal to 42. So angle ACB is 42 degrees. If angle ACB is 42 degrees, I hope you can see that angle DCB or DCE would also be 42 degrees because they're vertical angles. Now in this smaller triangle, DCE is actually our vertex angle and E is a base angle. So I'm going to subtract my 42 from 180. So 180 minus 42 is 138. I'll divide 138 by 2. And I get, what do I get? I get 69 degrees. So angle E is equal to 69 degrees. Right, so those are the three types of problems that you're going to see on today's homework. I hope this helps.